Next speaker, Professor Ching Huck from Universiti Malaysia, Kelantan, Malaysia. Hello, Huck. I request you to give a presentation on prospects of nanotechnology in improving fertilizer use efficiency in Malaysia. Welcome you, sir.
Greetings and good morning to the honorable organizer, speakers and participants of the international webinar on the role of nanotechnology in the current scenario. So before I begin with today's talk, please allow me to thank the organizer, St. Lawrence Institute Webcasting Center, Department of Botany, Sri Venkateswara University, India for giving me an opportunity to have a talk in today's international webinar on the role of nanotechnology in the current situation. So the topic of my today's talk is the prospect of nanotechnology in improving the fertilizer use efficiency in Malaysia, a new perspective from the conventional approach to nanotechnology. So next, this is the outline of my today's talk. So first and foremost, I'm going to give you an introduction and the background on today's world population and the food security crisis issue. After that, I'm going to highlight on the fertilizer demand based on the food security and the food demand issue in the world. So next, I'm going to give you a definition on what is the meaning of fertilizer use efficiency, and I'm going to highlight on what are the problems and factors that affect the fertilizer use efficiency in the agriculture sector. So after that, I'm going to highlight on a series of transition in the development of technologies in order to improve the fertilizer use efficiency in the agricultural sector. So next, I'm going to talk about the main topic of today's talk, which is the nanotechnology, and I'm going to also give you a series of proofs of the promising results provided by the nanotechnology in improving the fertilizer use efficiency in the agricultural sector. So after that, I'm going to highlight a few problems and questions to be pondered about nanotechnology in improving the nutrient use efficiency in the agriculture field. So after that, I'm going to summarize the whole topic of today's talk, and I'm giving you a final conclusion of today's talk. Alright, let's begin with the introduction part. According to the United Nations, the global population of 6.7 billion people is expected to reach 9.2 billion people by the year 2050. So in this slide, you can see that by the year 2100, India, China, and Africa are going to be the top 3 countries having the highest population in the world. So in this slide, we also can see that there's an increase in the population in Malaysia too. According to the Department of Statistics Malaysia, there's an increase of the population in Malaysia from 29.4 million people in the year 2019 to 29.7 million people in the year 2020. So the food production will have to increase by double in 30 years in order to help solve what was cited as the current food crisis issue. Currently, one of the most important challenges to achieve the food security is the intensification of global food productions, as we need to increase the food production by 70% in order to accommodate 9.2 billion people in the year 2050. So as the global population continues to grow, agricultural production must also keep pace with it. So the global fertilizer demand has seen a good growth since the year 2000. The world fertilizer demand in the year 2000 was at about 140 million metric tons, and this slide we also can see that there's a significant increase in the demand of fertilizer in the US. Next, same goes to India. We also can see a significant increase in demand of fertilizer in India. So the commercial fertilizer is responsible for approximately 40 to 68% of the world's food production. And our responsibility is to develop and employ management practices that use fertilizer effectively and efficiently. So in the year 2018, fertilizer consumption in Malaysia was approximately 2,106.5 kilograms per hectare. And the fertilizer consumption of Malaysia increased from 175 kilograms per hectare in the year 1969 to 2,106.5 kilograms per hectare in 2018. Growing at an average annual rate of 6.82%. So this has indicated that there's a significant increase on the fertilizer demand in Malaysia every year. So the FAO estimates that 37 countries are facing a food crisis issues, and this could be due to the increased demand of the food in developing nations, high oil prices, high fertilizer prices, low global cereal stocks, and some market speculations. Now, the food security is one of the great challenges facing humanity nowadays. Researchers and policymakers have identified a few approaches such as better rainfed agriculture and irrigation management, genetic engineering for producing high-yield crops, precision agriculture, drought-tolerant crops, and several other factors required to develop a new agricultural approaches as critical long-term strategies to feed the world. However, these policymakers and researchers say very little about the role of fertilizer in this scenario. So many believe that plant biotechnology is the whole key to the producing more food in the world. And the genetics and biotech industries have assured us they can deliver an increased yield, promising leaves the genetic yield potential of 3 to 4% per year. And also the world's largest seed company, Monsanto, also said that they can develop new variety of the corn, soybean, and cotton that will yield twice as much as grain and fiber per acre while using around 2/3 of the water. So these kinds of technology advances will be required if we hope to feed the world's hungry. However, history suggests that genetic advances alone may not be able to solve the world's food shortage or food crisis issues. After highlighting the food crisis issue, we can see that fertilizer also plays an important role in helping to solve the food crisis issue. This is because most of the food comes from plants and animals, and these plants also need to be fed by fertilizers in order for them to grow. However, not all soils in the world are able to provide sufficient nutrients to the plants, and this is where the fertilizer will come in to solve the problem by providing the major nutrients required for the plants. So basically, there are 17 essential nutrients required for plant growth. Besides carbon, hydrogen, and oxygen, plant nutrients can be divided into two major groups, micronutrients and micronutrients. Macronutrients such as nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur are required by the plants in a very big quantity, whereas the micronutrients like boron, chlorine, copper, iron, manganese, zinc, and nickel, they are all required by the plants in a very small quantity. So the fertilizer comes in different forms such as mineral and organic, which is in the natural form, and this fertilizer can also be produced industrially to become synthetic organic and inorganic. People might be asking how to measure the efficacy of the fertilizer being applied, which is able to provide the maximum uptake to the plants and the maximum use. So the answer is, in order to measure that, fertilizer use efficiency is the measurement for us to measure the ability of the crops to take up all the nutrients and utilize the applied fertilizer for maximum yield. So in the normal season, farmers usually will only yield approximately 30 to 40% of the fertilizer use efficiency. It is very impossible for them to reach 100% of the fertilizer. There are several problems and factors that affect the fertilizer use efficiency. The first one is the soil. There are many different types of soil available throughout the countries in the world, and because of these differences, different types of soil will have different in terms of the physical, chemical, and biological properties. And because of that, it will affect the way how they retain the nutrients in the soil and making them available to the plants. So this is where it will affect the fertilizer use efficiency. Next, some countries have high precipitation rate, in which could pose a high risk on the rate of fertilizer being washed away from the soil by rainwater. So sometimes human errors such as the wrong application technique by the farmers and also the wrong timing of fertilizer application or wrong quantity could also affect the ability of the nutrients to the plants, and causes like excess application of fertilizers will pose a risk of nutrient leaching and thus reduce the fertilizer use efficiency. So as I mentioned earlier, different types of soil will have different properties, and depending on the properties, some soil, especially those acidic soil, will contain a lot of these aluminum and iron ions, whereby they can cause the fixation of certain nutrients in the soil, which makes them unavailable for the plant uptake and thus reduce the fertilizer use efficiency. In addition, the forms and types of fertilizers also affect the ability of the fertilizer to provide nutrients in a fast way or in a slow way, and sometimes they can also easily lost by volatilization and thus causing a reduction in the fertilizer usage. This slide shows the volatilization of ammonium from applied nitrogen fertilizers, which creates a huge drawback to agricultural sectors, especially surface applied urea fertilizer, where its efficacy constantly reduces. So upon application, this urea will hydrolyze in the water, and the UVs will trigger the ammonia loss. So the conversion of ammonia to ammonium ions speeds up during the hydrolysis process. So the ammonia volatilization causes poor nitrogen use efficiency by the agricultural crops and simultaneously increases the air pollution. Not only that, in order to overcome the nitrogen loss increases the agricultural crop nitrogen use, farmers tend to apply excessive nitrogen, which creates environmental problem, and at the same time it is very costly, because when you apply excess of these nitrogen fertilizers, some of these fertilizers will be leached away into the underground water bodies, because not all 100% of the applied fertilizer will be absorbed completely by the plants. So when these nutrients leach into the water bodies, and these nutrients tend to accumulate in the water bodies in the long term, especially nitrogen and phosphorus, then it will trigger the environmental problems such as eutrophication, which is the algae bloom. So once the bloom of the algae happens, it will inhibit the penetration of the sunlight and oxygen into the water bodies, and thus affect the aquatic organisms in the water. So next, we can see that this is another problem in the soil which causes leaching, because the potassium in the soil itself is highly mobile, which means that they can move a lot. So let's say if you have an inappropriate physical properties of the soil, then it might also affect the speed of the moving of this potassium ion. So when this happens, then if you apply too much of this fertilizer and you didn't amend or repair the soil based on this condition, then it will pose a high risk of this potassium leaching into the underground and leach away. So thus it will reduce the fertilizer use efficiency of your fertilizer. So next, this is another problem which happens in Malaysia with the fixation of phosphorus. Now, in Malaysia, most of our soils are acidic in condition. So once the soil is acidic, aluminium and iron always present in a very large quantity. So this aluminium and iron, they are positively charged. So when we apply this phosphate fertilizer, P fertilizers, this P phosphate, they are negatively charged. So because of the huge large quantity of this aluminium and iron ions, which are positively charged, they have a very great affinity towards the negatively charged phosphate ions. So once they bind together, they will form a solid insoluble compound. So this solid insoluble compound will not be available for plant absorption and uptake. So thus, this will reduce the fertilizer use efficiency of your phosphate fertilizer. So after realizing the problem and factors that reduce the fertilizer use efficiency, in this slide we can see there's a transition in the development of technologies to improve the fertilizer use efficiency, starting from the very old-fashioned way, regular application of fertilizer, to today's famous technology called nanotechnology, which is the core topic of today's talk. So in the olden days, farmers tend to apply fertilizers regularly and in large quantity in order to saturate the nutrients in the soil to boost the crop yield. However, this approach is not only costly but does not guarantee high fertilizer use efficiency. It also creates a lot of this environmental problem. This is because excess application of fertilizer will not guarantee 100% of the absorption by the plants, but most of them will be leached away through underground into the water bodies, and some will be washed away by the rainwater. So once the water bodies accumulate these nutrients, especially nitrogen and phosphorus in the long term, it will cause eutrophication problem, which is the algae bloom. So the bloom of this algae on the surface of water will reduce the penetration of sunlight and oxygen into the water, and thus affect the survival of the aquatic organisms. After that, researchers and scientists realized that there is a positive correlation between the soil pH and the soil available nutrients. So this is where the timing approach takes place in order to raise the soil pH from acidic to near neutral to enhance the ability of the soil nutrients. However, some farmers have a misconception and they tend to overlap the soil without testing the soil pH, to the extent the soil pH rises to alkaline state. So once the soil pH becomes alkaline, it creates another adverse reaction. So the overliming causes a lot of these calcium ions to be present in the soil. So these positive charged calcium ions will bind with the negative charged phosphate ions from the applied phosphate fertilizer to become a solid compound and not available to the plant uptake. Thus, it reduces the fertilizer use efficiency. So this mechanism is similar to that of this aluminum and iron in the acidic soil. Oil palm has been introduced to Malaysia in the early days, and the planted area started to grow and increase since 1960s. So the crop has brought much revenues to the country. Besides oil palm, Malaysia also planted a lot of this sago, pineapple, paddy. However, these crops create serious agricultural waste problem because not all parts of the plants are consumable. So the problem has become more and more serious to the extent causing pest and disease infestation. So in more cases, these wasted plant parts such as rice straw, rice husks, pineapple leaves, empty fruit bunches, sago baggage were being burned on the agricultural site straight away because they are the fastest and easiest way to overcome the waste problem. However, they are not environment friendly because it can cause a very serious air pollution problem. So some of these yield being harvested also subjected to the industrial processing. So this industrial process also created a lot of this byproduct waste, such as decanted cake and palm kernel from the oil palm. So researchers have been carried out to look into how to overcome this waste problem in a sustainable and environmental friendly way. So now I'm going to share with you some of our research studies by converting the pineapple leaves waste into compost. Well, the term compost might sound a bit very old-fashioned and nothing new in the agriculture field, but this perception is not always true. This is because most of the time people only look at the function of the compost itself in providing the nutrients to the soil. So in this case, we are using the compost to serve as an organic amendment to amend it with the chemical fertilizers and to amend the soil condition in terms of physical, chemical, and biological properties. So in doing so, we are taking advantage on the compost surface area, because once the compost has reached maturation stage, the mature composted compost will produce a very large surface area full of negatively charged. So this large surface area is similar to that of these nanotechnology fertilizers. So this surface area, which is very huge, very large, and full of negative charges, they can improve the oxidation of these nutrients on its surface and thus reduce the possibility of this leaching and loss by volatilization. So they can retain and improve the cation exchange capacity. So by doing so, by applying this into another biological approach, the term biological agriculture comes in. So same goes to the biochar. Biochar itself also comes from charcoal, and the charcoal is also a very old-fashioned thing. But when we use it and apply it in the biological system, like what I mentioned just now, then it has become a biological amendment. So this is where the biochar, the name biochar comes in. So in this case, a laboratory scale incubation study was carried out to assess the effects of amending the organic amendment with nitrogen and phosphate fertilizers in reducing the phosphorus fixation problem and ammonia volatilization problem. So at the end of the study, soil with the treatment of organic amendments T2, T3, and T4 produce more soil availability compared to T1, which is the chemical fertilizer alone. So we also can see that treatments with organic amendments significantly reduce the ammonia loss compared to T1. So this has indirectly improved the fertilizer use efficiency by providing the retention of the nutrients in the soil for longer period to allow absorption by the plants. At the same time, the large surface area of these organic amendments such as compost and biochar was able to chelate these ammonium ions and also the aluminium and iron ions, which cause the fixation on the phosphate fertilizer. So this surface area with a large quantity of negative charge, they have a greatest affinity towards the aluminium and iron ions. Thus, we can chelate them instead of this letting the aluminium and iron to go and bind this phosphate fertilizer. So this phosphate fertilizer will then become more freely available for the plant uptake. So after that, the same approach was tested in the field trial by using the maize crop as a test crop, and the maize produced 2 and 3 crops per plant under treatment applied with the organic amendment. So, and at the end of the trial, plant tissues analysis also show that there is a significant increase in the nutrient uptake, and this concludes a significant improvement in the fertilizer use efficiency. After that, we did testing in the paddy crop too. In the experimental plot, similar observation can be observed where the paddy applied with the organic amendments produce higher yield compared to chemical fertilizers alone. So the trial was further tested in the farmer's field, and again, same observation was observed, and it tends to speed up the maturing stage of the paddy. So in this slide, you can see there's a difference between the chemical fertilizer alone and the one on the right-hand side, which is the one applied with the organic amendments. So it tends to speed up the maturing stage of the paddy. And again, the graph has shown an improvement in the nutrient recovery in the soil, which in terms indicates there's a positive improvement in the fertilizer use efficiency. So the time passes, more innovations have been carried out in order to further improve the fertilizer use efficiency. Innovations like coating the chemical fertilizer has shown to further improve the nitrogen use efficiency. So as you can see in the table, those coated urea fertilizers produce higher nitrogen uptake compared to the urea without any coating. And in terms of nutrient use efficiency, the coated urea produces a higher and better efficacy. So after that, more advanced innovations comes in, such as precision farming, Internet of Things IoT, to further improve the precision of the fertilizer application. So in Malaysia, some plantations such as oil palm and paddy field has adopted the use of drone to apply the fertilizers. But however, there is still a very limited research data to compare its efficiency in enhancing the fertilizer use efficiency. So next, we move to today's modern technology called nanotechnology, which is also the core topic of today's talk. So the recent advancement in the fabrication of nanomaterials of different sizes and shapes have yielded their wide array of application in medicine, environmental science, agriculture, and food processing. So throughout this history, agriculture always benefited from these innovations. So nanotechnology is the revolutionary technology where the particle size ranges between 1 and 100 nanometer, at least in one dimension. So due to their high surface area and high reactivity, better penetration into the cell, these can activate plants and microbial activates, resulting in more nutrient use efficiency. So the nanotechnology has been introduced in the series of agricultural field for crop improvement, crop protection, precision farming, stress tolerance, soil enhancement, and crop growth. So what makes the nanotechnology enabled fertilizer so special in improving the fertilizer use efficiency compared to the other approaches? Well, from the perspective of surface area, the nano-fertilizers possess a small particle size which causes increased surface area. So this increased surface area raises the nano-fertilizers' reactivity with other compounds and thereby increases the nutrient use efficiency and nutrient uptake. On the other hand, in terms of the solubility, nano-fertilizer with the solvents as water possesses increase the solubility. So the excessive solubility of nano-fertilizers increase the nutrient bioavailability in the soil by solubilizing and spreading of insoluble nutrients in the soil, and they are also very less dependent on the irrigation system. Next, in terms of the particle size, nano-fertilizers have a particle size of much less than 100 nanometer. So due to the decreased particle size in the nano-fertilizers, diffuses into the plants and increase the uptake of the nutrients. And thus, it can help to improve the fertilizer use efficiency. Now, in the aspect of encapsulation of nano-fertilizer, the encapsulated nano-fertilizer increases the available and nutrient uptake by the plants. So zeolite-based encapsulated nano-fertilizers enhance the ability of the zinc and nitrogen to prevent from denitrification, volatilization, and leaching of nutrients in the soil. And lastly, in terms of the nutrient uptake efficiency, nano-fertilizer has increased uptake efficacy and limited the leaching loss of applied fertilizer because they control the release of the fertilizers bit by bit according to the plant needs. So this can reduce the risk of leaching and also run off by the surface area. So next, I'm going to share with you some of the latest proofs of nanotechnology in improving the fertilizer use efficiency. So in the let's take a study by the Abel Aziz et al. 2016, application of the nanoparticles such as zeolite was able to reduce the nitrogen loss from the fertilizer. So in the diagram, we can see the beehive structure of the zeolite itself, which increased the surface area that chelate the ammonium ions, especially the positively charged ions, from allowing to be lost by volatilization. So this is very suitable applied in the Malaysian soil, especially the acidic soil, whereby the zeolite itself also has a pH of near to neutral. So when they raise the pH of the neutral, it tends to enhance the availability of the soil nutrients, and also due to its surface area of this beehive structure, it helps to increase the surface area and thus capture all these ammonium ions and prevent it to loss by volatilization. So thus it will improve the fertilizer use efficiency in this aspect. So in the next study by Nail et al. 2010, the urea fertilizer treated with hydroxy apatite nanoparticles was able to release 12 times more urea compared to the pure urea to be absorbed by the plants and increase the fertilizer use efficiency. So again, once it is treated with these hydroxy apatite nanoparticles, it will release the nutrients slowly according to the plant. So once they release more slowly according to the plant needs, then when we count back, the release will be much higher compared to the one provided by the urea without any coating with the nanoparticles. Because the pure urea without any coating with the nanoparticles tend to release the nutrients very fast, and because they release the nutrients very fast, thus most of the nutrients will be lost by volatilization process. So on the other hand, the pea fertilizer loaded from the surface modified zeolite also has a higher accessible period, constant percolation. And yet again, this approach is very suitable in Malaysia acidic soil, because once we release the phosphate ions slowly from the surface modified zeolite, then it can reduce the chances of it being fixed by these aluminium and iron ions, which are positive charged. And again, once it reduces the fixation of the P, then it will enhance the availability of the nutrients for the plant absorption and thus improve significantly the fertilizer use efficiency of phosphate fertilizer. So next, in a study by Sabah et al. 2014, the application of nano-calcite with the nano silicon oxide, magnesium oxide, and the iron oxide not only improve the uptake of calcium, magnesium, and iron, but also enhance the uptake of the phosphorus and micronutrients zinc and manganese, which directly improve the fertilizer use efficiency. Because in this case, once you improve the uptake of the nutrients into the plant can use it to produce more yield. So in this term, it will improve the fertilizer use efficiency. So in the next study by Liu et al. 2009, the application of carbon nanoparticles together with the fertilizer improved the grain yield and fertilizer use efficiency significantly. And again, similar observation was observed in the study by Kale et al. 2016, showing the application of zinc nanoparticles together with the fertilizer not only improved the fertilizer use efficiency, but also improved the crop productivity. And yet again, this one we can see that once they are applied into the soil, they can release it slowly, making the nutrients always available for plant uptake for maximum absorption. So once the plant can absorb maximally, then they can produce more yield. And this will improve the fertilizer use efficiency in this situation. After reviewing all the positive findings and reportings from the application of nanotechnology in improving the fertilizer use efficiency, there is one question you need to ponder about. So the question is, does the nanotechnology application will pose a risk to the soil health or even human health? Now, so far what we can see is all the researchers have reported a positive effect of the application of nanotechnology in improving the soil nutrients availability. They also improve the nutrients uptake by the plants and also improve the yield of the plant. And for example, like the plant uptake of this nitrogen, phosphorus, potassium, and other nutrients compared to the commercial fertilizer without any nano application seems to be unproblematic, and they seem to be very promising. However, what is unproblematic at the macro scale might be problematic in the nano scale. Because why am I saying this? Because currently there is a very limited study that would enable the risk assessment on these nanoparticles even in the research and development phase of the products. And there's a very limited study has been identified that will allow the identification of a point of departure for risk assessment. So what we can see here is more work need to determine the impacts of these nanoparticles on the soil health and plant uptakes before any fine-tuning begins. Furthermore, the method of this application of nanotechnology-enabled fertilizer will mediate the risk to farm worker health and inform the design of protective equipment to mitigate those risks. For example, it seems unlikely that nanotechnology-enabled fertilizer could be broadcast or even side-dressed without farm worker inhalation of nanoparticles not bound in the fertilizers. So airborne fertilizers nanoparticles could put the farmer at risk of damage to the lungs or maybe other organs. So my point of view is researchers have to assess and improve the suited evaluation techniques to investigate the impact of these nanoparticles and nano-based fertilizers on the biotic and also the abiotic factors of ecosystems. So among the various issues, the accumulation of these nanomaterials in the soil would possibly be the necessary issues to look into. So as a summary, the application of nanotechnology is able to improve the fertilizer use efficiency. As we all know, the enhancing nutrient use efficiency is a commendable goal and ultimate trial handled by the agriculture and fertilizer industry in the worldwide. So the nano-based fertilizer consists of a higher surface area because of lesser in the size of nanoparticle, and they have high reactivity solubility in the water, which is less dependent on the irrigation. And the nanotechnology enables the nutrient to be encapsulated inside the nanoporous particle, whereby these fertilizers are able to release the nutrient in a slowly manner to the crops and increase the fertilizer use efficiency. So besides, it also helps to overcome the problem faced by the problematic soils found in Malaysia that reduce the fertilizer use efficiency. So in the conventional fertilizer, the fertilizer use efficiency is always very low, which is around 30 to 40%. So this mud delivery systems of nanotechnology approach will enhance the nutrient ability and the use efficiency. So the fertilizer used effectively in 10 to 25% for phosphorus, but with the nano-fertilizers rising as a substitute for traditional fertilizers, the build-up of nutrient in the soil and thereby eutrophication and the drinking water impurity problem may additionally be eliminated. So in fact, this nanotechnology has opened up new opportunities to enhance the fertilizer use efficiency and limit charges of environmental protection. In conclusion, nanotechnology-based fertilizers seems to provide a very promising finding and effects in improving the fertilizer use efficiency. And this approach has a very good prospect in Malaysia, especially when in Malaysia we have those 4 major problematic soils, whereby the application of this nanotechnology could help to improve the fertilizer use efficiency when the fertilizers are applied in these 4 major problematic soils in Malaysia. And as a recommendation, the risk assessment, especially of the application of nanoparticles in the soil health and human health, should also be highlighted and look into this problem. Thank you so much for your attention and your time. So I hope to see you again next time. As an acknowledgement, I would like to thank the organizer of the webinar conference again for giving me an opportunity to have a talk for today's webinar session and also providing the great hospitality. So next, I'm going to thank Universiti Malaysia Kelantan for providing the research facilities and also the Ministry of Higher Education Malaysia for providing the research funds. Thank you.